This code comparison shows two ways to handle the same test setup. On the left, the test is buried under manual class instantiations and setup hooks. On the right, all that complexity is handled by passing a single to-do page argument. You're already using this pattern every time you call the built-in page argument. By using the test.extend function, you can build your own custom arguments that follow that same logic. Instead of repeating the same setup steps in every before each hook, we move that logic into a centralized layer. This allows the test file to focus purely on the user actions and assertions. The first step is centralizing your page object models. We want to reach a point where your tests no longer need to manually create page classes or track their lifecycle. In a custom fixture, the function receives the base page object and a special use callback. Logic written in the green block runs as setup. The yellow line, the use callback, executes the test. Finally, code in the red section runs as teardown. Because both setup and teardown live in the same block, Playwright can guarantee that every test gets a strictly isolated environment. If a test fails, the code in that red teardown block still executes, preventing resource leaks or leftover data. When you run tests in parallel, locking in through the UI for every individual test creates a massive performance penalty. Playwright lets you define fixture scope. Worker-scoped fixtures run once per process, sharing state with all its tests. To set this up, we use tuple syntax. The fixture function is wrapped in an array, followed by a configuration object setting the scope to worker. You then override the default page fixture to depend on this worker-scoped account. Every test now automatically inherits the authenticated state from its worker, skipping the login UI entirely. This moves authentication from a repeated UI bottleneck to a one-time background task, accelerating your parallel execution and removing login-related flakiness. Some tasks, like debug logging, need to run on every test. However, you don't want to force your developers to include an unused logger argument in every test definition just to trigger the code. Try to write this yourself. Use test.extend to create a debug log fixture. Use the tuple syntax to set it to auto-true, and see if you can use the test info object to check the test result. By setting auto to true inside the tuple, this fixture will execute for every test in the project without being explicitly called. Notice that we place the if statement checking the test status after the await use call. This ensures that the fixture waits for the test to complete before checking if it failed and needs a debug log. This approach decouples infrastructure logic from the actual test script, allowing you to add global behaviors without touching your test files. Let's look at the final execution flow. The process starts when the worker spins up and executes the authentication fixture once to handle the sign-in state. The individual test then takes over, receiving the page object fixture and performing its specific actions. If the test encounters a failure, the teardown logic begins. Finally, the auto fixture detects that failed state in its teardown phase and processes the logs for the report. This matrix shows the three patterns we've built: explicit page object fixtures for UI logic, worker-scoped fixtures for shared state, and automatic fixtures for background infrastructure. Mastering these three structures separates simple test scripts from a modular system, where setup, state, and logging are completely decoupled from your test logic.